In this problem, we need to prove the following. So we'll begin from the left hand side. So what we'll do, we'll first consider the numerator, which is 1 plus cosine theta plus iota times sine theta. Now, we can combine 1 plus cosine theta because that is a trig identity, which is given by 1 plus cosine of theta equals to 2 times cosine squared theta over 2. Also sine theta, we can expand it by using the half angle formula. So this will be 2 times sine theta over 2 times cosine of theta over 2. That means we have 2 times cosine squared theta over 2 plus iota times 2 times sine theta over 2 times cosine of theta over 2. Right. Now we can take 2 times cosine theta over 2 as the common factor. So this will get multiplied to cosine theta over 2 plus iota times sine theta over 2. Right. Now, similarly for the new denominator, we have 1 plus cosine of theta minus iota times sine theta. So if we use these two trig identities, then this reduces to 2 times cosine of theta over 2 multiplied to cosine of theta over 2 minus iota times sine of theta over 2. Now, we can rewrite the expression within the parentheses as 2 times cosine of theta over 2. So this will get multiplied to cosine of negative theta over 2 plus iota times sine of negative theta over 2. Right. The reason why we're doing this, we know that cosine of negative theta, that's positive cosine theta, and cosine and sine of negative theta, that's negative sine theta. Here we can use the De Moivre's theorem. We can rewrite this expression within the parentheses by rewriting it as 2 times cosine theta over 2. So this will get multiplied to cosine of theta over 2 plus iota times sine theta over 2 whole raised to the power of negative 1. Right. So this is what we have done using the De Moivre's theorem. The De Moivre's theorem states that if we have cosine of theta plus iota times sine theta whole raised to the power of n, so this will be equals to cosine of n theta plus iota times sine n theta. So that will be equals to, so in the numerator we have 2 times cosine of theta over 2 multiplied to cosine of theta over 2 plus iota times sine theta over 2 whole divided by 2 times cosine theta over 2 times cosine of theta over 2 minus iota times sine theta over 2. So this whole will be raised to the power of n. Now we have 2 cosine theta over 2, 2 cosine theta over 2 cancelling out, and this is simply this is positive raised to the power of negative 1. So this entire denominator goes to the numerator, combines with it to give us cosine of theta over 2 plus iota times sine theta over 2 whole raised to the power of 2 raised to the power of n. So that means we'll have simply 2n. Now applying the De Moivre's theorem, we have cosine of 2n times theta over 2 plus iota times sine 2n times theta over 2, which gives us the value cosine of n theta plus iota times sine n theta. So this is now proved. So let's do a numerical based on this particular idea. So here we have this is raised to the power of 18. Now in this particular case, our theta value is pi over 9 and our n value is 18. So here we have already shown that this value must be equals to cosine of n theta plus iota times sine n theta. Now we will replace the value of n and theta here. So our n value is 18 and our theta is pi over 9 plus iota times sine. Now our n value is 18 and our theta value is pi over 9. And that means we have cosine of pi 2 pi plus iota times sine 2 pi. The cosine 2 pi, that value is 1, and iota times sine 2 pi, that value is 0. So that means the value of this particular expression must be equals to 1.